This is the K1 building where the Laboratory of Design for Cognition conducts experiments.
So here is the lounge. This is where we meet visitors, make some presentations. We have a view here on the project space, which we will see later. It's a comfortable place for talking, taking coffee, but also having various kinds of demonstrations of all the IT systems which we create here. Why a laboratory of design for cognition in an electricity company like EDF? Simply because half of the workforce is white collars, that most of the others use computers, and that efficiency now heavily relies on swift and accurate information processing in front and back office, on flexibility and coordination. This means a lot of new processes, new organization, new agency, and this is why we do research on cognition. The use of information technology to make production processes better means deep changes in the organization of work, of the knowledge of people, of how to transmit it, of how to organize the distribution of work, information flow between people and machines. We have noticed inside EDF and in 17 other large companies which we have audited that the state of the art for white collars is not satisfying. People feel that they are overloaded with information, which we call the cognitive overflow syndrome. They tend to lose focus on long-term goals and try to clear off their desk of the constant flow of incoming information. We are trying to build empowering environments using IT in a way that people will be central again in the process. Designing the transition towards an IT augmented, more comfortable and efficient environment means deep changes in the organization. And this has to be done with the people. We try here to produce, design the new working environment for white collars, but we don't do it for white collars, we do it with them. Because as Volker Hartkopp says, what you do for the people, you do it to the people. And this is not our approach. We want to involve all stakeholders and users in the design itself so that they can reappropriate, feed in the process, use their own creativity, and create together what will be an environment where they feel well and produce well. And now we enter the control zone of the laboratory in the project space. On the right here, the entrance to the RAO room. Our goal here is to support activities with major cognitive components, such as what white collars are doing or professionals. And our principle is to leverage the installation which supports the activity. Human activity is determined and guided and supported by the world as an installation. This installation is distributed in the environment at 3 levels. The first level is the physical layer, that is objects, chairs, software, walls. The second layer is in humans. Representations and practice are installed in people's minds and help them interpret the affordances of the environment. How to use this software, how to use this chair, that kind of thing. Representations and practice are the second layer of distributed, installed mediating structure in people's minds. The third level also determines and constrains what people can actually do and their behavior. Those are rules, and this is the institutional level. Helps us keep the global house tidy and people's behavior predictable. Our strategy is to support human activity by helping the environment guide and sometimes constrain individual activity as the subject goes through the world to accomplish the task and fulfill the goals. Our strategy is to gradually reorganize and upgrade this installation with the stakeholders and the users. And we do so at the 3 levels, considering what is easier or more efficient to solve some existing problems. Sometimes we will change the objects or create new ones, for example, new devices, new software, which provide services. Sometimes we will create here new representations, practices, provide mental models who help people make better use of existing environment, or simply to use the new objects which we introduce. Sometimes we will have to work on the rules, because these are the ones that make the behaviors predictable, and for common work and collaboration, it is necessary that people indeed share the ways they do things. So we will act on one or another level depending on what seems more efficient or easier or simply preferred by the users and stakeholders. One difficult issue in changing the world as an installation is that everything is connected, especially in a large company like, or an industry like EDF. When you touch one activity, this may have impact on many other activities and on many stakeholders. One user interacts with a lot of people, with the maintenance, with the procurement, with the management, with other processes, and so we must be very careful when we change something in the world, because this world is common. For example, if you want to help the accountants and produce a new workflow for procurement, this will certainly help very much the people who are in charge of procurement. But this may, and it often happens as we all know, bring a lot of problems to other people in the chain, the ones who need these procurement process. So the way we proceed is very careful and gradual. We try to make some changes at some level, see what are the impacts, and depending on those impacts, change a little bit until the global organization and system has found a new equilibrium. So our strategy is to gradually reorganize the world at those 3 levels I described: physical, representations, and institutions. And we do that in real conditions. How do we do it? We designed a large vivarium where real people do their real work and test our new environments. Here, users can organize the setting exactly as they want, very quickly, in a matter of moments. For example, all the tables are movable, the chairs are stackable. We have the capacity of providing network, power, video, voice, whatever you like, very quickly. For example, we have power plugs that come from the ground. Network is ambient. PCs are mobile. And we try to make the affordances very easy to use and fit with the mental model of the people. For example, suppose I want to set up a video conference with Salle Berlioz in Chatou. I just put that on the antenna and I'm connected. People prefer easy to use and friendly systems. We try to provide fluid user experience with no technological transition between what people want and the execution. For example, this is my computer. Anywhere I am in the company, I can have direct access to my virtual machine. Of course, I will have to enter my password. a matter of seconds, I have my usual environment. Here's my email, right? But I can have access just about to anything on my disks, wherever I am, at any place. And when I leave the room where I'm in, I take the tag, and my machine disappears. So it is secure. In our quest to make interaction fluid and easy for users, we came up with a series of basic minimal requirements for collaborative systems. One is zero training. It's a list of zeros. People have no time to learn. They're here for working. So we must try to use the pre-existing knowledge skills which are installed in people's minds. For example, they know how to use the internet, they know how to use Windows, they know how to use the company software. We try to provide services of which the first use needs no new knowledge, so they can on the fly, at first use, have already some good experience. Zero configuration, zero user maintenance, zero impact on user workstations. We try to have systems which do not touch people's existing environment, which are their own. And sometimes they don't know how to change it, sometimes they don't have the right to change it, sometimes it's difficult or hazardous. So we just try to have systems, typically web services, which have no impact whatsoever on people's equipment. Zero complication. This is a classic HCI guideline. Things should not be further than 2 clicks away. €0 is interesting. It's an organizational problem. If the user has to pay something before use, this is an obstacle. We try to have the way completely free for the user and make someone else pay in the organization before the user has access to the system. Immediate benefit for the individual end user. Of course, people want to help the general organization, they want to comply to rules, they want to be good, but first they need to have some kind of individual benefit. This is the reason why people very often do not clean rooms, do not clean disk space, etc. Because what are the positive externalities are difficult to obtain directly from people, at least before they really like the system. So we try to have systems which are beneficial for the individual end user and of course for the group. And of course we have to be compliant with the security rules of this company, which are pretty severe. These conditions are only conditions for deployment. They are not sufficient, but they are necessary. In our experience, systems for collaboration which do not fulfill all these criteria, or at least most of these criteria, have little chances of disseminating or will cost intense efforts to users and require strong pressure from the organization to disseminate. We applied those principles for meetings because collaboration is one of our core targets. But we tried to be realistic. Some of our first versions of support systems tried to help people process the meeting agenda. What do you come for in a meeting? Process the meeting agenda? No. This is only one of your objectives. First, we checked if people actually know the meeting agendas, and we discovered, as we should have expected, that a lot of people do not know the meeting agenda. This is, of course, for meetings where people had the meeting agenda beforehand, which is always the case here. Many people come with only a vague idea or know only a few items of what is supposed to be dealt with in the meeting, and some come with no clear goals, some come with goals which are different from the meeting agenda, some come with goals which are only the meeting agenda, but these are a minority. What are the other goals that people have in meetings? Well, touching base with distant colleagues, physically seeing them, or having high bandwidth communication with them. talking to someone hard to reach, solving problems informally. This is absolutely crucial. Now, in a company, as in any organization, you have many rules, but a lot of things, a lot of problems, especially new problems which have to be solved, have no rules or have to be solved slightly not exactly by the rule. This is what is called informality, and without informality it is impossible for any organization to work, because conditions are changing and the rules are always from yesterday. So when people come to meetings, of course their goal is part of the common goal of the participants, that is to process the various items of the agenda, or at least some of them. But they also have other goals, informal goals, sometimes goals that cannot be told, but these goals are absolutely necessary for the good operations of the system and of the company. And a good environment should be able to support these goals as well as the other goals of processing the agenda. This is what we learn by looking at actual meetings. There are so many meetings here, 210 only last year in multiplex. We record all those meetings in detail, we analyze what happens, we try to understand all the problems, discuss with the users, and try to find technological solutions which help them, but also sometimes organizational solutions, different rules. And we install and scale out new meeting rooms, better meeting rooms, based on the experience that we have here. We enter the control zone of the laboratory in the project space. On the right here, the entrance to the RAO room, or conference room. The building was, before we took possession of it, it's a building that was constructed in the 1950s, and it was completely reconfigured, reinstalled. And this was done with the help of several teams with whom we work. The building infrastructure was designed by our colleagues from Carnegie Mellon University, the Center for Building Performance and Diagnostics, Volker Hartkop, who's here on the picture, Vivian Luftness, Azizan Aziz, and other colleagues. We also use here many systems and devices which we co-develop or have in tests from various laboratories, people from Fuji-Xerox Palo-Alto Research Center, University of California at San Diego. Here's Jim Holland on the picture, also Ed Hutchins, Aaron Sicorel, who is our advisor, and also here you will notice wearing a subcam Professor Valery Nosulenko from the Academy of Science of Russia, who happens to be here in Paris today. And maybe Valery, you can join us. And Valery and his colleague Lena Samolenko, also psychologist from the Institute of Psychology, were here for the from 2000 to 2003 continuously, and helped us set up the whole protocols and observation techniques, and they introduced us also to Russian activity theory, which we use on a daily basis. Because we use here, and this is something typical of this laboratory, a lot of new techniques for observation and analysis of human activity. A lot of things that we have here come from other laboratories, devices, things that were developed in collaboration with our colleagues at UCSD, Jim Holland, Ed Hutchins, Aaron Sicorel, people at Stanford Center for Innovations in Learning, which maybe you'll see later, software from FXPAL, and many others. The walls are movable, so this conference room can be reorganized, made smaller, larger, and users actually continuously change the shape of the building as new people come in, go out, new projects settle in this project space, and everything is under continuous observation. You will notice what we call OFSATs, office satellites, On the ceiling here, we've got about 30 in the building. These are time-lapse video camera servers, which provide us with a continuous view of what happens in this building. So we have seen here the RAW room. Now maybe we can see the project space. So this is the main project space of LDC. This glass cube is where we can isolate. We have two of them. It is absolutely necessary to have some isolated place where you can do deep work when you work in a project space, open space like this. This is also designed as a small video conference room, so we can have multiplex little meetings. It is very comfortable. When you are inside, what you say cannot be heard by people out there, which is convenient, but also you don't feel inside a little cube because it's all full of windows and light. Now, this space changes all the time. Currently, we have here Antoine Cordelois, PhD student who works on the relation of users to augmented environments and homes especially. Antoine, can you tell us a little bit about what you're doing and present this panoramic camera?
First, I can start by describing what this thing is. So it's a 360 degrees camera composed by six CCD camera which are taking up to 30 images per second, and using an optic fiber cable it's going to a compressor, and it makes some 360 degrees movie. We can see an example of what kind of movie is produced by this camera here, with the overview of the currently recording video. So to make it more understandable, we could use a comparison with a paper that you opened. The world is seen by someone which is in the middle of a circle, and we open that circle to have a flat video. To work with this kind of panoramic video, we use Diver, which is a tool to analyze and explore the 360 degrees video. An evolution of Diver will be also presented. It's Web Diver, a web-based solution.
So we have here a lot of running experiments, some of which we hope will produce interesting services and environments for the EDF workers. Another of our PhD students, Sophie Lebellu, a cognitive scientist, who is working on the transmission of knowledge inside the company, and uses widely the subcam and also the Diver software.
Je vais présenter ce que sont les subcams, caméras subjectives. Il s'agit de caméras qui se portent à hauteur des yeux, de manière à récupérer le point de vue de celui qui la porte en situation. Donc ici, on trouve donc une caméra qui se porte sur des lunettes avec tout le matériel qui permet d'enregistrer et qui est portée par la personne. Il s'agit d'une des premières caméras, d'une des premières subcams qui a été développée en 1998 donc, par Saadi Lahlou.
You see that she has slightly turned her head to the left while drinking her coffee. Hence a post-it note with a telephone number and a name comes into the center of her visual field and catches her attention.
À ce moment-là, ce type de caméra était plutôt utilisé pour récupérer l'activité de personnes qui travaillent dans des bureaux essentiellement. Maintenant, on passe sur des problématiques pour récupérer les gestes professionnels dans le domaine nucléaire. On s'adresse donc à des opérateurs qui vont devoir porter des casques. Pour ça, on développe donc une nouvelle version de subcam qui s'adapte directement sur le casque de la personne qui le porte.
Je relâche le linguet, ainsi le sectionneur est verrouillé, il ne peut plus changer de position. Mon circuit de puissance est maintenant opérationnel.
Good to see you. Welcome.
Our colleagues from Academy of Science in Russia have a meeting today with us. And so as everybody who enters the building, they signed in from consent because everything is recorded. So for privacy issues, rights of image, we ask people who visit the building to write an informed consent where they have full control over their image.
Encode a lot of different file formats and codecs.
No, many different video.
Yes. A lot of the server side we have an encoding of this file. It was a V, so it's at the end server side.
No, some